that we've completed our wildcat, we're ready to put the well on production. But first, we need to appraise the field before we start any development. We need to ask some questions like, how much oil is in place in this area? How big are the boundaries? How many wells are we going to drill? What is the spacing between the wells? Are they going to be close together or far apart? These are the questions that we need to answer so that we can maximize our recovery over a reasonable amount of time. If you remember from Chapter 5, present-day technology does not allow us to produce 100% of the hydrocarbons found in any given reservoir. For example, lighter hydrocarbons with more hydrogen molecules have higher production rates than heavier ones with more carbon molecules. Other factors affecting the rate of production might include the types of primary drives found in the reservoir or secondary drives introduced into the reservoir that are used to force the oil to the surface. In other words, the final percentage of hydrocarbon retrieval from a particular well and reservoir not only depends on the type and quantity of the reservoir's hydrocarbons, but also on other factors like viscosity, porosity, permeability, and pressure encountered. That said, know that final percentages of overall production can be greatly increased by good engineering that includes good planning. Suffice to say that the opposite is also true. Therefore, pausing for a brief period to run a few more tests in what is known as best practices in field appraisal, the overall productivity of the well and the field can be maximized. In Chapter 9, we will explain and illustrate the equipment and procedures involved in field appraisal and development that will help you get answers to the questions just raised at the start of this lecture. Where needed, we'll highlight the similarities and differences between onshore and offshore field development. Starting with onshore, we'll describe the equipment, the production tests, and procedures used for a field appraisal and emphasize some factors that must be present if the exploration field is to become a production field. Next, we'll describe the equipment and procedures needed for site development of service facilities that need to be in place as the field is brought into production. We'll discuss those facilities that need to be on-site and some safety and economic concerns that might affect the placement of these facilities. In discussing offshore field appraisals, development, and site preparations, factors such as the depth of the water and the intensity of the wind and waves exclusive to offshore field development will be addressed. We'll conclude by looking at well workover units that are designed for wells that need to be reworked or refitted due to falling rates of production. Illustrating workover units, we'll then explain how these units are used for various conditions. Overall, in this chapter, we'll explore the various methods used to maximize field development during the time that the field is being appraised and then produced. Before getting into details of the equipment and procedures involved in field appraisal and development, let me walk you through a quick outline of how an exploration well evolves into a production well. During this transition phase, the exploration team's first step is to conduct an initial potential test, or IP test, before a preliminary field appraisal can be prepared. It is the data obtained from this test that will help guide the development for this field appraisal and will include a plan for step-out drilling and well spacing. Once the decision is made to go forward, however, this exploration well will become a production well. At this point, the first thing that needs to be changed is usually the expertise required by the well site engineering team. As you might imagine, skills needed for successful exploration differ from skills needed for successful production and field development. For example, exploration engineers are expert in selecting where to drill a wildcat well with only incomplete knowledge about the subsurface. Production engineers, on the other hand, have access to much more information and data that was collected by the exploration team. This data, along with other information, will most certainly include drilling logs, coring results, data from the productivity tests, and the wireline formation testing and logs. The most difficult aspect of the job of the production team will be to successfully and accurately interpret this data to maximize oil recovery. Let me point out here that unlike wildcat exploration wells, development wells are almost always successful because the reservoir has already been located. It just has to be defined. So let's get started. As explained in Chapter 7, the last of the 3 production tests performed in a completed but still termed exploration well is the initial potential IP test. The last of 3 productivity tests, the IP test is run after drill stem and wireline formation testing, along with other indicators, have shown positive signs of potential commercial quantities of hydrocarbons in the well. Because the purpose of the IP test is to better understand the well's actual production rate, real-time production conditions are created. These evaluations will help guide the final decisions in the field appraisal. Performed after the well has been put into production for at least a few days to allow treating fluids to be retrieved and cleaned up, the initial potential test is run over a period of about 24 hours. In that time, the actual number of barrels of oil and water and the cubic feet of gas that is produced is carefully measured. In addition, surface tubing pressure is recorded. The data retrieved from this final productivity test then allows the exploration drilling team to better judge the potential of the well. If the decision is made to proceed based on both engineering and economic input, then this well and its field will be marked for further appraisal and then developed. Before we continue, let me discuss some of the challenges faced when we run an IP test. Even experienced engineers, when looking at IP data, can be misled. For example, completions in some types of reservoirs come in at a high rate initially, but then decline rapidly over the next few weeks, thus rendering the reservoir uneconomic. It is therefore recommended that a wildcat well be produced over a period of time before committing to an ambitious drilling program. In addition, gas reservoirs have their own special challenges when conducting IP tests. Because of the natural volatility of gas when attempting to contain or transport it, this gas is usually allowed to vent directly into the atmosphere during an IP test, unlike oil, which can more safely be collected into tanks. Due to environmental concerns, therefore, the amount of time that this gas is allowed to vent into the atmosphere is usually shortened. Because of the shortened period of time, the data collected during the IP test on a gas exploration well can sometimes result in less accurate assessments. Another problem with gas fields, again, lies in the properties of this highly flammable gas and its unique requirements for retrieval and transportation. For example, if gas discoveries are made some distance from a pipeline, a number of wells have to be drilled before adequate gas reserves can be established to justify laying a pipeline into this field. For these reasons, predictions for future gas production may depend on more testing. This, coupled with the need for more complex equipment to both produce and transport this gas, can result in delays in the project's development and more upfront costs. After the IP test, For either onshore or offshore wildcat wells, the exploration team endeavors to define the outer perimeters of the pay zone. In most cases, equipment used to drill the wildcat well will be used in the initial stages of field appraisal. This means that jackknife rigs and remote rigs will continue to be used in land operations, while barges, tenders, jackups, drill ships, etc. will be used offshore. For a full description of these rig types, please see Chapter 6. For subsequent stages of field appraisal and development, additional equipment will be brought on-site to enable production. Now let's look at the most common procedures involved in field appraisal and development. Step-out drilling, well spacing, and if necessary, infill drilling are all common procedures involved in appraisal and field development. Step-out drilling is done after a successful IP test. It helps identify the size and shape of the field for calculating its future economic value. With structural anticline traps, the team of engineers begins by analyzing seismic maps acquired previously during exploration to determine the spill point of the structure. If you remember from Chapter 3, when we spoke about structural oil traps, the spill point is the lowest point in an anticline trap that contains hydrocarbons. Think of a glass of water that once filled to the brim, the water will spill over if you add more. Like the liquid in the glass, once the crown of the anticline structural trap has been filled to its spill point, further accumulation of hydrocarbons cannot occur due to lack of space in the trap. These hydrocarbons will then either leak out to the surface or be captured by another trap as they migrate towards the surface. Wells drilled to find the spill point are called delineation wells. These delineation wells are drilled around the wildcat well in order to find the spill point, which will be indicated by what is known as the oil-water contact line, or OWC. Again, explained in Chapter 3. If the reservoir is full of oil, then the OWC will be at or near the spill point. On the other hand, if only water is encountered, this indicates that there is no oil-water contact line and that this delineation well is outside of the boundaries of the pay zone. It will be abandoned as a dry hole. When an OWC is not found, the team will continue to drill until they find it. In this case, another delineation well will be drilled closer to the wildcat well. Additional wells, all called delineation wells, are then drilled encircling the wildcat well to establish the parameters of the pay zone as defined by OWC. Let me point out here that many delineation wells in onshore drilling will most likely go on to be producing wells. This may not be the case for offshore delineation wells. Newer technology and offshore development is greatly changing how offshore fields are developed. Like most aspects of petroleum engineering, in both onshore and offshore drilling, caution needs to be exerted when evaluating data from step-out drilling because the porosity, permeability, thickness, and/or pressure can change or disappear at any point, thus affecting the quality of the reservoir.